How's it going, everyone? Welcome, Gabriel Gonzalez again, and today we're going to explore now about the deep dive into JavaScript, right? So, why am I doing this? I'm going to make a quick recap of what we went through this to get a little bit of context, and that is that at the end of the day, if you want to be a competent JavaScript developers, you need to know how to read the spec and therefore see what are the features that are available in across platforms, whether it is the browser or the server. So for the server, you have is Node.js and recently now Dino and Bon. And for the browser, you have the uh, Chrome, Firefox, Chakra, or any of the Chromium-based browsers. The thing here is that despite of all of these environments, JavaScript, the engine, the language, is now run on each one of those. And if you are familiar with this, and if you are competent, if you know what this tool does for you, a lot of the time that will save you time debugging and understanding what's going on behind the scenes. Therefore, you can now be much more effective, competent, and efficient when it comes to solve these kind of issues. So that's great. That's the reason why we are looking at this, and thanks to Carl Simpson that help us to organize this in a way when we can now is like a lookup table access that data or this content quickly. So this was laid out in 3 pillars. So you have now the type system, something that we're continually looking at, the scope, and then the objects orientated, right? So for the type systems, so far we have looked at the reason to be able to read the spec in this numeric algorithm way, so we can know what's going on here, especially when we read or when we do stuff like this, right? When we do stuff like this, like hello, right? So what is this? And this is a single operator or unary operator that what it does is the same as the number, all right? Which is trying to make this value and turn into a primitive. So because of that, we look at first as the primitive values and the object values, and understand the set of values that we can get from these values. For example, with type of and null, undefined, string, number, symbols, big int, and boolean, as well as the object, right? And when it comes to the primitive, the undefined, null, string, boolean, number, symbol, I think there's something out there, objects, exactly, it's this 7 type, right? But I think there is, and big int, exactly, because it's 8. So you have undefined, null, boolean, string, number, big int, symbol, and objects. But the first 7 here is this primitive, is this atomic values that you cannot break down. Now, we also look at what are the values that we can expect when we are evaluating this primitive. So for all of them actually works as expected, except for the null. And there is an historical reasons here, because if you want to unset a primitive, you use undefined in ES1. But if you want to unset an object, which means that free spacing memory, you use now null. This is the reason why type of give you now is, or one of the reasons why now type of give you is the object type of, right? So the TLDR is that this is a bug, so you have to be careful when you're using null in that regard if you want to check that. Now, we also look at the kind of emptiness, undefined, undefined, and the undefined, uncreated I call, but this is undeclared, undefined, undeclared, and uninitialized, and different in each one of those states. So undefined is when you create that, but you haven't provide a value. The undefined is that you didn't even create that, and with initialize that you created, but the value is not initialized with undefined per se, which is something that happened. This is true for let block scope variables, for example, like let. So once we know the bigger picture and understand now this, we also look at the special cases of values that we can have. So for example, like nan, positive and negative zeros, and what this stands for. So nan at the end of the day is an spec from the Institute of Electronic Engine, the Institute of Electric and Electronic Engineers, 754, that they say, hey, you know what? This is this is the way how we're going to represent now numbers. All right, this is finite because our memory is limited, and therefore we can represent up to 2 power 53. In other words, in decimal is a 9 followed by 15 digits, right? So if 3 represents thousands, and 6 a million, and 9 a billions, and 12 a trillion, 15 a quadrillion, right? So for big integers that we want to represent, let's say, you know, astronomical distance, or fractions in cryptography or finance, right? So we want to represent that kind of numbers, right? We use now this big int, and the big int is the only type that doesn't do this coercion, something that we're going to talk about that later. So isNam is that, all right? Is a non-represented, it represents a non-valid number in this range. Therefore, the actual value of that, if you want to check what is the value of nan, is a number with type of, and nan is the only value that is not equal to itself. In other words, if you compare true to true, it tells you true. A number with a number is a number, give you that is true as long as the number are the same. The same for the string, the same for booleans. It's interesting. I was going to check now for symbol. You say, hey, symbol the same as symbol. It is true. We also have now the primitive, and the non-primitive is an special kinds of objects, such as array, right? Or function. But in this case, it must be like this, right? Or functions. So for example, if you want to know the type of a function, whatever function it is, all functions return nothing, it'll give you this. So you can say, hey, is this type of function are the same? In terms of value, they are the same, okay? But with NaN, that's not the case, right? It's like, what the French stuff is this? So 9 is the only value that doesn't do that. So, and this is the way of how you can verify once you receive now this value, they are not the same. So therefore, if for example you receive one value that is an N and you want to compare that with another that is an N, the best way to do that is by doing this, right? Again, this is because NaN, because how do I know this? Because of the spec. NaN it's not it's not an identity value, right? Unlike any other values, it's not the same as it is identity. So this is good use case for NaN, and the other is the positive and negative 0. So for example, if you say this is the same as negative 0, you say, hey, this is false. And this is because any place when a Boolean operations needs to happen, okay, it's going to now do this abstract operation, which is the way of how now deal with this type conversion, this type transformation. There's a lot of transformations that the language does, this abstract operation. You can conceptually think of these algorithms that JavaScript is doing behind the scenes. You can have access to that, but you can get the benefit from that when you need to do. So this abstract operation, which is a lot, all right? There's a lot of abstract operation here, but the most relevant for us is for to primitive, to number, to string, and to Boolean. Again, this is true because most of the time we are going to work with this type of values, and because of that, we really care about what's going on behind the scenes. We also have this the to int, all right, the abstract operation to int form, which is you want to create now is a is an array that is in a particular range. It returns either a normal completion containing an integral number and throw completion. It converts arguments to one of 2 power 8 integral number values. In the inclusive interval from this, it performs the following step. Let the number to number, which is this particular primitive that now, as I mentioned, we look first at the to primitive. It just wants to continue to read this. It performs the following step when called. If number is not finite, or number is either a positive or negative 0, it's going to return always a 0 here, a positive 0. Let int be truncate. Okay, this is an operation. Remove the fractional part, all right, by rounding 0 towards zeros. It's like I only care is the integer part. Truncate that number, and let now the integer 8-bit be an int model of this. In other words, it's like whatever values you want to store here, it must be in this particular range, right? 2 power 8, and 2 power 8 is 128 minus 128 to 127, right? And you get the idea, right? So if the integer is greater than this, return now is these operations, right? Otherwise, return is this. But the idea here is you can now have all of these different primitives. But what we really even for this to property key, okay, another primitive takes a value and returns either a normal completion, a property key, or throw a completion. It converts arguments to value that can be used as property key. Exactly. It converts arguments to a value that can be used as a property key. It performs the following step. The whole idea of this is we're going to look at the most common, relevant, primitive, or abstract operations in this case, so we can have now an idea of what's going on behind the scenes, as well as understanding concepts like boxing and what's the other one? Boxing and the corner cases. So, to a primitive, what it does is this is an abstract operations that it takes now that input as a primitive value, or whether it is a primitive or an object, all right? And then now provide some hint to this, which is the preferred type, okay? So, we can summarize this into ordinate to primitive. We can summarize this into into two main operations, whether it is the to number, or whether it is the transforming that primitive into a number or into a string, right? So, for the to string, or for transforming it into a string when it receives the hint as a string, it say, hey, I'm going to run now the to string first, and then the value of, and in the reverse order when this hint is a number. So we know what is the expected values. All right, let me see if I can get this, but it's interesting. To string of or value of, else the method name be value of to string of. Get that is callable. If result is not an object, return the object. And then type exertion. So the thing here is that when the language wants to evaluate, when you try to pass now a primitive, because at the end of the day that's what it's doing, is like trying to convert this into a primitive, all right? So if you pass now a primitive value, it's going to transform that into those relevant values, which is here, all right? So if this is now, for example, a number, we're gonna get now a number of this. If this is a string, we're gonna get that the string, all right? So this is exactly, this primitive is going to attempt to coerce the value at some expression into a primitive, and the process to do that is by passing a hint. Again, this is something that JavaScript is doing, not us. And if this string is going to console these two operations, to string and value of, and if you get your value, therefore it will return the primitive value. Again, to primitive is going to give you the outcome of this is a primitive, right? And a primitive values, those primitive values that we looked before, right? Undefined null, boolean string, number, big int, symbol, or an object, all right? Now, when we look at the to string, which is going to receive now this argument, and it's going to coerce or transform into a string. So for primitive value or a string, I would like to use this word. It's kind of weird, but it's kind of what happens. So stringification of primitive is you say you got the null, undefined, true, false, and all of this, and it correctly transformed into now a 0. All right. So how do you check that? Stringification of primitive. So if you, for example, now have something like this, the best way you can check this is by wrapping this into this function construction. Then you say, hey, again, this is to string, exactly. This is to string. So you want to convert is now string, and then you got it. Right? This is the great place of how you can check what is the expected value that is gonna give it to you, right? So the stringification of primitive is like that. It's interesting because we don't consider but negative and positive zeros are primitive as well as the isNaN, right? So even if you receive NaN, what will be the expected that you can get from this, right? Since isNaN is a type of number, all right, I'm assuming that I'm going to get is now what? A string with NaN? Exactly. Exactly. You get it. Whoever gets that has a good intuition. Whoever gets that, in my case I was, has a good intuition of what's going on. Okay? So far, so good. Now, this is the stringification of primitive. What about stringification of objects? Especially stringification of this kind of stuff. Exactly. If you give you now empty, if you provide now the values, if you give you only the values, if you provide now null or undefined, you see, it gives you now this, and if you now pass is several values like this or nested values, so this is kind of the things that you might expect when you're trying to transform is an array. What about objects? Okay. What will be the expected value here? In my case, I know what it is, but if you for some reason have saw that out there in the boonies, this square bracket objects, object, an object with the second word, the first letter capitalized. Then you are now effectively looking at that JavaScript is performing this type coercion on this object. All right. So if you have now an object, it give you this. It say, hey, this is an object, but again, it's not very intuitive. It's not even descriptive here. So it doesn't express the intention of the code. Besides, it tells you that this is an object, but it doesn't tell you is that what is the value of this if he wants to dive into this. So for example, say, hey, like 2, right? So if you want to know the shape of this, one way to do that is by overriding the primitive value that you can have access, like to Boolean, to string, and to primitive. I think to primitive you can to primitive you can have access to primitive. You can have access. There is no to primitive, but there is a to string, which is global. All right, and also there is a to number. No. Oh, only to string? Okay. Well, the to string, you can say, hey, since this is a function that is provided for me, I want to now say, hey, what is the string value? But I want to look now at the particular object here. How do you do that? Well, you say, hey, this function here, I want to now is override the behavior that you have here, and therefore return now, for example, is some value. Right. Again, this is something that you're not going to do that a lot of the in the wild. It's just a way of how you can override that particularly coercion that happens on objects, stringification of objects. So the more interesting case is with the two-number, because it involves more corner cases. So here, because we want is to do this numberification of a string, initially let's go with primitive. You say, hey, if this is 0, okay, if this is positive 0, if this is negative 0, if this is nan, right? No issue. If this is null, it's 0. If this is undefined, if this is nan, it's like, what the French toast? All right. And if this is empty, oh, this is 0. If this is true, or if this is false, so for primitive, or the numberification of string, it actually does what is expected, right? It actually is smart enough. It removes also the trailing zeros, okay? And is smart enough to detect even if now hexadecimal values in a string. You say, hey, I think OX 16, you know. So good. Again, this is now the numberification of a string. But what about the Boolean true or false values? You say null is 0 and undefined is nan, right? So yeah, this is one of the things that I get in here, like 0. I am not a big fan of this null to be 0. Why wouldn't they just define nan as a null as well? In any case. And now the numberification of objects. This is quite straightforward, which is say, hey, this is not a number. Reasonable. Reasonable. The same for arrays. Oh. Now it said this is 0. So if you pass now this, so this is to say, hey, this is not a number. However, if you pass now null or undefined, all right, it behaves the same. If you pass now a nested, it gives you now the value inside of this, but only 1. All right. And this is now how you, and also let me try is the another primitive like negative 0, good, positive 0. All right. We also test with is nan. Okay. So the point of this is that when this is an empty string, okay, when this is an empty string, it gives you now 0. This is when you started to realize that empty string in JavaScript is the root of all evil. Why is this? Because when we analyze now is the Boolean here, okay, when we analyze the Boolean value here, and somehow and somewhere we say, hey, you know what? What about the Booleanification of strings and numbers? So for a string, you might say, hey, well, it's quite straightforward. There is no algorithm to do this because from the spec, it has now a finite set of elements. It's like a lookup table, if any of them are not part of this, it's true T value. In other words, it is much better to memorize is the falsy value because it is a smaller list, where you say now here is, hey, if this is not, if their value is 0, undefined, null, positive or negative 0, or is or nan, no, or undefined, exactly. Oh, grab. Oh, grab. So if those values are 0, if the values are 0, negative 0, null, undefined, makes sense, makes total sense, false, or empty string, then it is automatically a falsy value. So here now, the empty string in JavaScript, in the type system coercion, it is something that is the root of all evil in JavaScript. So anything that is outside of that is a true T value. And there is a huge set of stuff that can be. It can be in a string with things. It can be now. It can be now empty string. All right. It can be a string with some spaces. All right, because it's a valid character. It can be a number, it can be an object, it can be an array, it can be a function, it can be a nan, the value nan. No, but interesting. Let me check here. It's okay. Nan makes sense. So it is much more effective to memorize that. So if the Booleanification, which is any time that you don't need a Boolean value where a Boolean is needed, this operation happens. So, as I mentioned, so this will be is false, undefined will be false, nan will be false, which is good, nan will be false, 0 will be false, negative 0 will be false, false will be false, quite obvious. But anything else, right? Anything else, and the empty string, okay, and the empty string will be false. This is when you now analyzing stuff, and this is when the coercion kicks in, right? So this coercion, this type conversions give more precedence to string concatenation rather than the numeric operation. All right. So how do I know that? Because when you read at that, say for example the addition operation. Let me take a look at that. The addition operation. This is on operators. Abstract operators. The addition operator here. The addition operation either performs string concatenation or numeric addition. But again, it tells you that this is the first stuff that it does that. But I think this is exactly, and the evaluation. It's a return the evaluate string or numeric binary expression. Here, additive expression and the multiplication. The negative or the subtract operation performs subtraction operation because it doesn't make sense to produce is or to subtract string, So this is the left shift operator. Perform a bitwise left shift operators on the left operand by the amount of specified by the right operand. Okay, this is bitwise operations. In my case, it's much like fun facts rather than do actual stuff in real work. All right. Um, if you want to do some optimizations, uh, good. Most of the time, you don't need that. Unless, again, if you're doing now optimizations, that might be a good candidate for. Um, the void operator, the type of operator, the unity plus operator, and unity minus operator. So this one, but I think, oh, there is a difference between, yeah, because the unity operator converts it is operand to number type. This is different. This is different because this is unity operators, and I want to look is at the addition operator, but this is a clause. Language expressions, and the other is, okay, language expression, unity operators, and additive operators, like this, right? So the addition operator either performs string concatenations or numeric addition, okay? So why am I showing this? This is 12.8.31. It seems that they changed that 12. Lexical grammar, okay. 12.8, spuntuator, literal. They changed now on the spec. 12.8, the addition operator. Runtime semantic evaluation. If you say now runtime semantic evaluation, okay. Primary expression, all right, okay. Rounding operator, grouping operator, relational runtime semantic evaluation, the if statement. That's interesting. They don't have anything like this. There you got it. Evaluate string or numeric binary expression. Evaluate string or numeric binary expression. Oh, it seems like they shrink this. Addition operator. That's quite interesting. So the addition operator, exactly. Runtime semantic evaluation, exactly. Now they shrink that into this. It says return whether it's the evaluate string or numeric binary expression, additive expression or multiplication expression, or additive expression, like this. And it's a evaluate string or numeric binary expression. And here you have now what's going on. Here, let the ref be evaluation of the left operand. The abstract operation evaluates string of numeric binary expression. Takes argument of the left operand, a parse node, objects a sequence of Unicode points, and right operand here. Either a string, a big int, or a number, or an abrupt completion. It performs the following step when called. Let the left reference be evaluated by of the left operand. The left value get the value here. Evaluation, runtime semantic evaluation, which is the syntax direct operation evaluate takes no arguments and return a completion record. Okay, this completion record that can be either normal statements, exactly. Normal statement, break, continue, return, or throw. So evaluate this normal statement. Let the value be now get the value ref. and then apply string or numeric binary operation. And this is now the algorithm, this abstract operation, this operation that JavaScript does behind the scenes. And you have now this. Begin multiply, begin add, begin subtract, or the numeric operation here. Give me a second here. I'll be right back. Let me actually go explore is this on the which version is this? Not quite sure. I am not quite sure. Oh, I know it is. No, I know where to look. I know where to look. 1.12 exactly, which is the ECMA 2018 version. Exactly. But I want to look at that. No, it's this one. Come on. Exactly. And when you look at the addition operator, now it tells you this. If the type L print is a string or type string is a string, then let string be to string and this to be to string. So if the type of L print, in this case, it tried to transform into a primitive, okay? And if one of them is a string, then I'm going to do now a string concatenation, return string concatenation, right? String concatenation. This is interesting because in newer versions, no hint is provided in the calls of primitive. In the new versions, they don't tell that S. You know what? So the addition, exactly, the addition operator is this one. The addition operator from 2018, okay. If you now take a look at this, the addition operator, it says, hey, I'm going to now run this stuff here, which is kind of the same thing here. Kind of, not the same. Runtime semantic evaluation, additive expression. Is this additive expression plus multiplication expression? This is the runtime semantic evaluation. Either it's an additive expression, that can be this. Additive expression like this. And this is the runtime semantic. Now they shrink this and say, hey, the abstract operation evaluates string or numeric binary expression, takes argument, left operand, a parse node, optext. Okay. So now they create this. So internally, the language created its own evaluate string or numeric binary expression. Its own function. Takes arguments, left operand, a parse node, optext, a sequence of Unicode points, and the right operand, a sequence of Unicode. Okay. And returns either a normal completion containing either a string, exactly, either a string, okay, and it returns an either normal completion containing is a string, a big int. Look at this. Now they are including in these newer versions of the language is a big int or a number or an abrupt completion. It performs the following step when called. Evaluate string or numeric binary expression. Let the ref evaluating here get the value of that, the left reference and the right reference, okay? And then apply string or numeric binary operator here, which is the abstract operation applies string or numeric binary operator, takes arguments, left reference or left value, the operator, the operator, the text, interesting. It's like, what is this kind of operation that we're going to do, right? And the right value, and returns either a normal completion, and remember, normal completion is now this particularly record. A normal completion record that specify is the behavior of that statement. All right, it's a runtime propagation of values. which has this type value on the target, which say, hey, if I could execute this statement correctly, a normal statement, or normal, exactly, a break, continue, return, so on and so forth. And then it's and return a value in MScript value language, primitive for an object, and returns either a normal completion containing either a string, a big int, or a number, or a throw completion. It performs the following step when called. If operand is plus, okay, then let me check now the primitive. Unlike the other, it is the same as you can see here. Let me now call the primitive of those values. If the primitive of the left is a string or a primitive is a string, then let the string be string and transform them into a string. The addition operator 2018 and the addition operator in 2025. 2026, 2018, and 2006. They maintain the behavior, they just abstract that operation here, they just expand a little bit to include now stuff like that. So if this is any one of them is a string, you're gonna do a string concatenation. At this point, it must be numeric operation. You know. So all right, all I do is this numeric operation. However, if the number of the left is a big int, then if the operator is this, you're gonna do the count exponential / or a bitwise operation. Let the operation be a struct operation associated with objects in the following table. Okay. Exactly. If the left is a big int, then whatever operation it is, run this. So in other words, okay, assert the left is a number. Okay. This is quite interesting because here is exactly telling you what's going on when this evaluation happen in a binary operation. All right. So now we can say safely to see, hey, if this is a big int, so for example, if the left operand is a big int, this is how you say that this is a big int, and then you have now this any operand, all right? He will try to perform that. You say this can convert big int to a number because they must be on the same exactly. They must be on the same big int. So big int doesn't convert, doesn't do forced coercion. You do it like this, you got this, you know? So it performs that operation. If this is a big int, only with big int. The magic here, quote, quote, happens when you say, okay, now, what happens if this is a string? Well, if the last operand is a string, anything that is outside of that, it'll be a string, right? So this is a string, all right? And then I do string, so I'm going to coerce that into a string. Interesting. Coerce that into a string. Exactly. I'm gonna coerce that into a string. And what is the value of an object into a string? object. Holy fuck. That's mind blowing. Holy fuck. Grab. Grab. So the other wild stuff is to say, hey, if this is an object, all right, and if you are doing now an addition operation, all right, and if any of them is for somehow in a string, I'm going to exactly, it's going to evaluate the primitive, and it's going to evaluate if this is a string. So this primitive, if you say now I have two objects here, okay, if this evaluating two objects is going to perform like this, it's gonna consider it's a string concatenation. Holy moly. It's going to do a string concatenation because they say, hey, I'm going to transform this into a primitive. What is the primitive value of this object? And from an array, it's an empty string, right? How do I know that? Well, it's an empty string, all right? And the other is, what is the stringification of an object? What is the stringification of an array? What is the stringification of an object? All right, because that's what it's doing here, and therefore it's going to now perform that operation, do a string concatenation. So no matter what you have here, but at the end of the day, it'll be like that. Holy French toast, bro. This completely, man. This is mind-bending stuff. This is mind-bending stuff that I love to ask this kind of question, bro. Hmm. Hmm. So that was mind blowing, mind blowing. So mind blowing. So um, so if I'm going to call now to primitive, and therefore I'm going to call now to I want to call now the primitive here, and try to convert into a primitive. And if this is now an operation, a primitive, a plus operator, I'm going to try to convert first into a string and then a numeric operation, right? So anytime you look wild stuff like an object or an array or a function, right? Followed by an addition operator, okay, it will perform automatically string operation here. So even though you say even for primitive, this is true for, if we say true plus it's going to convert that into a string here. So what's true? What is the stringification of a true value? All right, is 0. It is true, right? Say for false. Look at what it's doing here. Look at what it's doing here. Okay, here we go. Okay. Again, this is now primitive. Okay, so this is true. What is the value of true? Okay, because they are not strings, they are numbers. So the value of true plus false, so true is 1, and now this exactly is because it's evaluating is this. If the left operand is now a string, okay, then they're gonna do a string concatenation. If it's not, if I evaluate into, then they're gonna do a numeric, what I'm gonna call this abstract class, these abstract operations to numeric for that. This is part of the use cases and weird use cases. So here it say, because this is now a value that is not on a string, okay, it calls now the to numeric. When it calls to do that, it passes now a hint. Jesus, French, those guys. So it's I'm gonna perform now a numeric. I'm gonna perform now a numeric operation here, but I'm going to transform those Boolean values into a numeric representation. So, which is true is equal to 0, true is equal to 1, and false is equal to 0. And therefore, this is of course 1. Oh my God, Brendan H. I know, 7 days to make a language. Anyway, oh crap. So if you say now undefined, all right, plus, so what is the stringification of this, which is a primitive? It tried to coerce that into primitive, and if this gives you now a string, which is true, it will say, hey, I wanna now combine is undefined, this primitive, with this object, and this will give you now is my expectation of this is that undefined plus object. Exactly, you know? So because what it's doing behind the scene is to say, hey, I'm going to convert this left operator first into a string, okay? And then into a number, exactly, and then into a number. So in this case, like I want to try to convert this into a string, course the string value of this is true, right? But since it considered true as numeric values here, that's fucked up, because now true is considered a numeric value here, and when you do that, for example, with another Boolean value, it does this. Holy moly. So I'm quite familiar with this. So if you say now, for example, even for type of, and it's not gonna, this is not a valid statement. Oh, because his getting is the type of plus. Type of undefined, because it does this numeric conversion. Even though if you say this undefined, if give you a string, because I did is a coercion is like I say this to a number of undefined, and of course this transform this into a number, which is not a I think the value of this is not a number exactly. So that's what this actually is doing here. It's an undefined. That's what it's doing here behind the scenes. Okay. So we're trying to understand is the mechanics of the language. And holy moly. Okay. But big N doesn't have any conversion here. So for any primitive like null, if you add that now to a false value, okay, it's gonna attempt to convert that into a string. Look at this. Okay. So anytime that is okay, it's going to now try to evaluate this. If the same if same type is false, throw an error. Okay, if they are the same type, holy fuck, if they are the same type like this, if x is undefined and g is undefined, return true. If null is x is null and g is null, return true. Okay. He is giving you now the identity, the same type. Okay. This is interesting. If x is an object, it's gonna give you now, if you evaluate this, it's gonna give you now true. I mean, Jesus. Is this? If you evaluate this, it's a if x is an object and g is an object, return true. But with the same type or with the same value. So in any case, so the thing here is that we are looking now at this weird behavior that's not weird, that is the way how it does. So string concatenation has preference over numeric or addition string. So not only that, is that it is preferred to be explicit, and when it comes to now call these falsy values, it is preferred to be now coerce that with boxing and all the corner cases here. So because if you want to do a stringification of a number or an op or like this number null is 0, oops. So for example, what it does here is say null plus false, both of them, of course, it tells you that, or true, it gives you +1. But this is because of what's going on behind the scenes. Not to mention that if you say, for example, a positive 0 or a negative 0, so number is an empty string is a 0. So for example, here if you do something like this is this plus true. If give me here is now okay, it give me now true. Okay, it give me now true. Good. It give me now true. Okay, if you're trying to do this coercion, it give you now true. So because behind the scenes what it does is to say number, which is 0, and try to do this. So it's gonna call is the two primitive, and it's gonna check if any one of them is a string. If any one of them is a string, corner cases with that. And the root of all coercion or all evil is the empty string. And another interesting case is that this evaluation is say, hey, 1 minus 2 minus 3. So you might think that it's evaluating that in this particularly proper order, but the thing is that it's going to transform this 1 minus 2, all right? It's say, hey, it's going to evaluate this expression as a Boolean, which now a Boolean is a 1, and this 1 converts into 3, which of course is 3. But what happens when you now do stuff like this? All right, 3 is greater than 2, that is greater than 1, and it say I'm going to evaluate is this. All right, 3 is greater than 2. True now coerce that value into a Boolean, into a number which is 1, and then you say this is. So this is one of the reasons of these corner cases here. This is one of the corner cases. If you don't provide now is this is one of the corner cases when you are going to evaluate statements like this, or with this some edge cases. So that is mind-bending, mind-bending stuff, absolutely. And there is mind-bending stuff that's going on behind the scenes, and therefore, yes. So that'll be all for this video. Take care. Bye-bye.